Hey guys, Ms. Miklos here, and in this lecture, we are going to be talking about a brand new law called the Law of Sines, and we are also going to talk about how to find the area of non-right triangles. So the first thing I want to show you guys is our brand new formula for the day, and I should say this is one of three formulas, but sine of angle A over side A equals sine of angle B over side B. And this is what the law of sines actually is. It is just a ratio of the sine of an angle divided by its side. And just like in law of cosines, we know that we could use any angle I want as long as I use its opposite side. Okay, so we don't need to memorize equals sine of C over C equals blah, blah, blah over blah, blah, blah. I just need to know it is the sine of any angle divided by its opposite side. In some books, you guys will see the sides being the numerator and sine of the angle being the denominator, and that is fine as well. We just need to be consistent in how we are setting up our ratios. And so the question that might be in your mind right now is, when do I use each formula? And quite honestly, it should be pretty much common sense which formula we should use, because if I'm substituting into law of cosines or law of sines and I don't have enough information, that should be a big clue to me that I'm doing something wrong. But the way that it makes sense to me, I always think if we are talking about one angle, to use the law of cosines. And that means that I could either actually know that one angle, or I might be trying to find one angle. If we're ever talking about two angles, that's when I want to use the law of sines. And what you will see on this homework assignment is, even though it's mostly going to be law of sines, there's going to be some questions where it's open-ended and we can kind of do either one. Let's get straight into number one here. So we have side A is 52, angle A is 74 degrees, angle C is 38 degrees. What is side C? So based on this information, I can see that we have two angles, so I'm thinking that we should use law of sines. I notice that I have angle A and side A, so I'm going to use those to be a ratio, sine of 74 degrees over 52. And then we are also talking about angle C and side C. So I'm going to say equals sine of 38 degrees over side C. At this point, I want to go ahead and cross multiply. And I end up getting C times the sine of 74 degrees equals 52 times the sine of 38 degrees. I'm also going to divide both sides by sine of 74. So I end up getting C is equal to 52 times the sine of 38 divided by the sine of 74. And I just want to point out here that this set of parentheses is extremely important. I need to always close my parenthesis if I'm continuing to type in buttons after it. Okay, and the reason why is because I want the sine of 38 degrees, not the sine of 38 degrees divided by the sine of 74. So I need to close this parenthesis in order to get the correct answer. This parenthesis down here really doesn't matter. If you want to be on the safe side, then always close your parentheses and you will always be in good shape. So I can put this straight into my calculator, and when I do that, I end up getting 33.3. And not that we have a ton of information, but based on the information we do know, 33.3 would be a reasonable answer. We knew it was going to be smaller than 52 because angle C is smaller than angle A is. Finding sides using law of sines honestly doesn't get much tougher than that. Okay, but moving on to number two, this problem is a little bit more difficult. First of all, if I look at these two angles, I notice we have two angles, so I'm thinking law of sines. And I notice that I have C's, I have an angle and a side, so that is definitely going to be one side of my fraction, or I should say one side of my equation. So I have sine of 100 degrees divided by 18. And all of a sudden, if I look at the rest of my information, I kind of have a problem here because we need to find angle B, but I have no clue what side B is. And since we are brilliant Honors Algebra 2 students, I know I cannot use Pythagorean theorem with those two values because it's not a right triangle. So, if I'm trying to think about what I could possibly do, my idea would be, why don't we find out what angle A is? Because I know if I add up A, B, and C, it's going to be equal to 180 degrees thanks to my triangle sum theorem. So I have side A, I can find angle A, and then once I get that value, add that to 100 and subtract from 180. So this problem definitely requires a little bit more thinking. When I cross multiply, I get 5 times the sine of 100 degrees equals 18 times the sine of angle A. And then I need to divide both sides by 18. Now this time, I'm trying to find the sine of an angle, so I know that I need to use sine inverse. So I'm going to do sine inverse of 5 times the sine of 100 degrees divided by 18, and I end up getting that angle A is 15.9 degrees. So, to find angle B, I'm going to do 180 minus 115.9. And where 115.9 is coming from is that is angle A plus angle C. And I end up getting that angle B is 64.1 degrees. There we go. Okay, so this is a really good problem because it's not just simply plugging stuff in. We definitely need to think a little bit about what we are trying to find based on the information that was given to us. Number 3 is a little bit different. This time it's giving us angle A, angle B, side A, and it's telling us to solve for the whole triangle. And I really want to stress to you guys that it's very important that I show all of my work. Okay, most of the time we will get the exact same answer regardless of what method we use, but sometimes we can get answers that are slightly different due to the fact that occasionally we may be substituting in a rounded value. Because of that, I really need to show all of my work so that when I am grading it, I know that you got the correct answer. It wasn't just that you rounded incorrectly. So it's telling us to solve for the triangle, which means I'm solving for every single piece that I don't currently see. And so I'm actually going to start with finding angle C because I think that would be the easiest thing to do. And I'm going to do 180 degrees minus 106 degrees. And once again, that 106 comes from adding A and B together. And I end up getting that angle C is 74 degrees. So we didn't need to use any trig for that. We could just use our triangle sum theorem. But now I need to think, how can I find sides B and C? And we need to choose what we want to find first. I like order, so I'm going to find side B first just because that seems pretty and logical. So what I'm going to do here, I need to determine should I use law of sines or law of cosines. And at the moment, my only option would be law of sines because I do not have enough information to use law of cosines. The reason being, I only know one side of the triangle. That means if I tried to substitute into law of cosines, I would have two unknown values. So I'm going to go ahead and use law of sines, and I know both A values, so that is definitely going to be one of the sides of my equation here. So I have sine of 41 equals 120, And I'm going to try and find b first. So I'm going to say sine of 65 over b. So I'm going to skip a step here, and I'm going to cross multiply and divide all in one step here. So I have 120 times the sine of 65 divided by the sine of 41. Okay, and if that confuses you, you can always go ahead and do this step by step. But when I do this, I end up getting b is equal to 165.8. Now, some of you guys may be tempted to want to use Pythagorean theorem to find our third side, but we know better because we do not have a right triangle here. So we have options. You could either use law of sines or use law of cosines. It doesn't matter. We have enough information to be able to use either equation. Since this is the law of sines video, I'm going to go ahead and use law of sines, but on your suggested problems, you can do whatever you want. So I have sine of 41 over 120 equals sine of 74 over c. So once again, when I cross multiply and divide here, I get 120 times the sine of 74 over the sine of 41. And I end up getting that angle C, that side C is 175.8. And now if we look at all of these values, I notice that it makes sense because we know that the biggest side should be opposite our biggest angle. Our smallest side should be opposite our smallest angle. So that is always a good thing for us to be double checking. Okay, so this is law of sines. Remember, law of sines and law of cosines technically work with any triangle. The reason why we are specifically using them for non-right triangles is because I think that using SOHCAHTOA and Pythagorean theorem is quicker than this, and we can use that with a right triangle. With a non-right triangle, I know that's not even an option, so that's why I need to rely on these different methods. So the second part of this lecture, we are going to be talking about finding the area of non-right triangles. And you guys all know we find area of a triangle. You guys learned area equals 1/2 base times height. And that is lovely when we have a right triangle and I have my base and I have my height. But unfortunately, those aren't the types of triangles that we're going to be dealing with. Back in geometry, you didn't always have that, but they were always nice and kind of gave you what that altitude or that height was, so you had enough information to figure it out. And unfortunately, in Algebra 2, that's not quite going to happen. So our first equation, we use K to represent area, and I'm not sure exactly why we use the letter K, but the reason why we do not use A is because we already use A when we're talking about sides and angles. So our formula is K equals 1/2 AB sine of angle C. And a few things that I just want to talk about. Just like our other formulas, I do not necessarily need to use sides A and B, but it's just saying whichever two sides I use, we need to also use the included angle. Okay, and that is the mathematical term for this. The reason why it's called an included angle is because if I was drawing out this triangle, sides A and B actually form angle C, so it is an included angle. Now, if we didn't want to be mathematical, which I know some of you don't, we might notice we use every letter once, which that is going to be true. Okay, so that is our first formula. And you guys could be just fine if that's all you knew. Now, I like to do less work, so I'm going to learn another formula as well, which is called Heron's formula. Okay, it is named after the mathematician named, you guessed it, Heron. And what Heron came up with is that K equals the square root, yep, that's a long square root, and I'm going to need it all, of S times S minus A times S minus B times S minus C. And I'm pretty proud of how perfect that was. Anyways, you guys might be looking at this and recognizing A, B, and C are side lengths of the triangle, but what the heck is this S thing? And S is equal to what we call the semi-perimeter. And it is actually self-explanatory because we know a perimeter is when you add all three sides together, and semi means I'm dividing by 2. So it means that I'm going to go ahead and add all three sides of our triangle together and then divide that sum by 2. So I like using Heron's formula if all three sides are given to us, but if I did not want to memorize this, I know that if I know all three sides, I could use law of cosines to find an included angle, and then I could use this particular area formula. So let's start off with something pretty easy. It says find the area. A equals 40, B equals 20, angle C is 55 degrees. This is a beautiful problem because I have sides A and B, and they give us angle C, which is the included angle. So I'm going to do K equals 1/2 AB, sine of angle C. So my area is 1/2 times 40 times 20 times the sine of 55 degrees. Now, I've talked about this previously, but even though I always use parentheses for my notation for multiplication, whenever I put something like this into my calculator, I always use the times symbol. Okay, so it's just easier and less work. When I put this all into my calculator, I get 327.7, and since this is area, we do need to label it, and it doesn't tell us what type of measurement it is, so we're just going to be general and say square units. Now, if you wanted to abbreviate square units, that is fine with me. We need to label it because it is an area. So hopefully that one was pretty easy for everyone. Number 5, we're moving on to something a little bit tougher because here I have sides A and B, but they don't give us angle C. They give us angle A instead. So somehow I need to find angle C. And I'm going to go ahead and use law of sines. So I'm going to do sine of 120 over 40. And the reason why I would choose to use law of sines here is because we're talking about 2 different angles. Even though I'm saying find angle C, they don't give us side C. So I'm thinking that I'm actually going to find angle B here. And if I know these 2 angles, we could use triangle sum theorem to find our third angle. So when I cross multiply and divide, I get 20 times the sine of 120 divided by 40 is equal to sine of angle B. So in my calculator, I'm doing sine inverse of 20 times the sine of 120 divided by 40. And I end up getting that angle B is 25.7 degrees. What that means for me is that angle C is 180 minus 145.7. So I get that angle C is 34.3 degrees. And now I can go ahead and say the area is equal to 1/2 40 times 20 times the sine of 34.3 degrees. And when I put that into my calculator, I get 225.4 square units. Okay, so this is a good example of how I would integrate knowing law of sines and law of cosines with using this area formula, because we definitely need to be able to find the correct information to substitute into the formula. Our final problem of this lecture is asking us to find the area, but this time we are given all three side lengths. So I'm going to go ahead and use Heron's formula, but I want to stress once again, I could go ahead and use law of cosines and find a missing angle and then use the appropriate information into our other formula. But I want to teach you guys how to use this formula. So I'm going to go ahead and find the semi-perimeter, which means I'm adding all three sides together and dividing by 2. And I get that the semi-perimeter is 17.5. So our area is equal to the square root of 17.5 times 17.5 minus 7 times 17.5 minus 15 times 17.5 minus 13. And in fact, I'm just going to do some simple math and make this easier to put into my calculator. So I'm going to do 17.5 times 10.5 times 2.5 times 4.5. And the way that I got all of these values was just by subtracting those particular values. So now when I put this into my calculator, I get 45.5 square units. Okay, so at this point, we know how to find missing sides and angles of non-right triangles. We also know how to find the area of a non-right triangle.